Welcome back to our channel. In today's video we are going to see part 3 of the 5 series for Tetris game development using JavaScript. Please have look on previous part of this game development if you have not seen it before for continuity. You can watch step by step of this game development. Feel free to pause the video to relook on any lines of code. Hope you will enjoy to play the Tetris game developed by yourself. Before going to the video, please subscribe and click like button if not already subscribed. Checked all our 7 Tetris blocks and ensure that they are coming from the top of the row and comes till bottom, but it goes out of the screen. But we want the Tetris block to be placed correctly when it reaches its desired position. So before placing the Tetris in the position, we have to validate the move. There are 4 conditions that we have to validate before placing the Tetris blocks. First one is if it is placed, is the move that is greater than the last row, then we should not accept the move, we have to place it in the bottommost position. The second one is if it is going left side, that is if the column is less than 0, we should not accept that move and we should place the Tetris at the 0th position of the column. And the third one is if it is moving on the right side out of the canvas, that is if the column is greater than 10, that move is also invalid, we should place it at the rightmost, that is before column 10. And the fourth one is if there is already a Tetris placed, we should not overlap it, we should keep it above that already existing Tetris. So these are the 4 conditions. So we will validate the Tetris block move and then place the Tetris in the Tetris field. For that we are coming back to our cyclic function and we are into the if loop where Tetris next block is there, and when the count is greater than 0 we have incremented the row. So after incrementing the row we will validate the new position. So I will call a function valid move. If it is not a valid move, we have to roll back our new row. So we have to do decrement Tetris new block because this is not a valid move. After rolling back, we can place the Tetris. So I will call another function place Tetris. So now we have to define 2 functions, valid move and place Tetris. If not a valid move, we will roll back the row and place the Tetris. So before writing these 2 functions, we will define a const called as Tetris field, which shall be a 2-dimensional array and it shall be equal to the size of our canvas which holds the Tetris blocks. Here we have made a canvas of 300 by 300 and each block we have divided with the grid size of 30. Hence we will get a 10 by 10 2-dimensional array. Using for loops for row and column, I am going to initialize this Tetris field to the size of 10 by 10 and each array will be initialized to the value of 0. So within the innermost for loop, when column is 0 up to column less than 10, so that 10 columns per row. Our Tetris field matrix row by column will have the value of 0. As a procedure, for every row we will define the array. Okay, now we have defined the array called Tetris field, which will hold the blocks for each position at any time of our play. Now we will go back, and as needed we will start writing first function valid move. As mentioned, valid move will be checked inside the cyclic. If not a valid move, we have to roll back the new position and place the Tetris. So valid move has to check few conditions. We have already seen 4 conditions. That is, if the new move is greater than the maximum row, then that is not valid. The second condition is if the move is less than the column, that is less than 0, that is also not a valid. The third one, if the move goes greater than the column, that is greater than or equal to 10, then that move is also not a valid. And the fourth one is if there is already Tetris grid is placed in the Tetris field array, then we should not overlap with the existing one. Hence, that move is also not a valid. So I have started opening for loops to check for the corresponding present Tetris block element for each length of the row and the position of the column in the row. We will check if the Tetris block design is holding a value 1. This is the first check because we have the Tetris block of 2 by 3 size. So first we have to check in that 2 by 3 array if the value is set. Because the design for I is different, J is different, and so on. So for each block it's a unique design. Hence we will check within the block if the 2 by 3 what are the elements are set. So before that I will write a return false if the conditions are satisfied, otherwise true. True means it's a valid move for the function. So coming back to our if function, if the block is designed such a way that in this x comma y, if it is set, the first condition we are going to check is if the Tetris field itself, if the Tetris field itself already has a hope you remember the Tetris field is the const array we have declared now and initialized it to 0. We will check if in the Tetris field the blocks row plus the incremented x value and its corresponding next block column plus y. This is our fourth condition, that is if the Tetris field already has a grid filled with a value. If the Tetris field already has a filled in value, then the condition is not satisfied, we will return false. We will see how to set the Tetris field, as so far we have only initialized on declaring the array. The Tetris field will be filled at the function that we will write soon, which is the place Tetris. So here our fourth condition is, if the field, the grid in the field is already filled, then we have to return false. The second condition that we are going to check is, if the new row is greater than the maximum row of Tetris field. As we recollect, the Tetris field is a two-dimensional array of size 10 by 10. So to check if the new position of our current block is going out of the row, we will take the Tetris field first one-dimensional array's length. So Tetris field dot length. If that is less than the new position, again we have to return false. And the third condition that we are going to check is, if the Tetris next block column is greater than the Tetris field column, that is, if it is on going outside the rightmost portion of the canvas, which will be checked using Tetris field dot row dot length. As here we have defined our rows in each item as same, we can take any of the Tetris field. Here I have taken Tetris field of 0 and its length, which will give the column length. If the current next block column is greater than the maximum value of the column, then also we will declare it as false move or not a right move. And the fourth one is, when the Tetris block is going outside the left side of the screen, again it is not a valid move, hence we have to return false. So as we recollect, we are checking for 4 conditions, but before that we are seeing if the current block has a value set for that grid. First one is, if already the Tetris field has a filled in grid, then we will return false. Second one, if the Tetris block's new position is greater than the maximum length or the row allowed, then we return false. And the next two are when it is leftmost and less than 0th column position or greater than the column 10, then also we have to return false. If not, we can return true. That means it's a valid move and we can place the allow it to the new position. As we recollect, when it is not a valid move, we have to roll back this new row position and call a function called place Tetris inside our cyclic function call. So now we will go and define the function called place Tetris. Place Tetris, as the name indicates, we will place or fill the blocks in the 2 by 2 array, that is Tetris field. At any time, Tetris field will indicate the current filled in positions of the Tetris canvas. I have copied and pasted the for loops, first one for the checking if the blocks row has a filled in position, with the innermost for loop is up to the column to check if it is filled in position. So if the Tetris block of x of y is set, then we will place or set the Tetris field array with the Tetris block name. Before that, if the Tetris row is less than 0, that is, it is just above the topmost row, we will call the function display game over. If we recollect, in the valid function, that is to validate the Tetris move, we checked the left, if the Tetris is going out of screen on the left side, bottom side and rightmost side. If it is above the top of the row, that is validated in place Tetris. If it is above the bottommost row, we will call the game over screen, because all the blocks have occupied a row. Hence, it's not a valid move. If the row is greater than 0, then it comes within the canvas of Tetris. Hence, we will take the block name and place it in the Tetris field with the corresponding row and column. Here the corresponding row and column is Tetris blocks row plus the current x value, and column is Tetris block column plus the corresponding y value. This is all placed only when the Tetris block has a valid value and the row is not less than 0, that is, it is within the canvas. Then we will place our Tetris next block name into the Tetris field. So Tetris field at any time will hold the current design of the canvas. So in the cyclic function, if the valid is not a valid move, we will place the Tetris after rolling back the row increment. We will see a preview. We got the Tetris block I, which is fixed. We have just fixed as I. It is now placed at the bottom row. It is not going below or out of screen. This is because it's checked for valid move, and if it is invalid, we rolled back the row and placed the position. So it's placed again. We have not yet written the code to bring the next blocks randomly, that we will do subsequently. So what should happen is, after placing a block in the Tetris field, next block, Tetris block, should keep coming from the top. For that, we will ensure in the cyclic, if we recollect, sometime back we have commented out temporarily to fill the whole 10 by 10 Tetris block. So now we will fill the Tetris block if the Tetris field has a valid value. So not all the grids, not all 10 by 10 Tetris grids will be filled. It will only the blocks that have the Tetris field value will be filled with the corresponding block color, which we will get from Tetris block color array by passing the Tetris field value. As we reconnect, Tetris field is a two-dimensional array which gets filled by calling the function place Tetris. So the corresponding color is given through context.fillStyle, and only the corresponding grid will be filled. And now we will go to our place Tetris. After placing the Tetris, we will call the next Tetris block, and next Tetris block we can get by calling get Tetris next block. So when our first Tetris comes, it is placed at the bottommost position, and we can see the second Tetris started coming from the top, and it is placed above the previous Tetris block because we are validating the position and not allowing it to overlap. So now we are getting the Tetris block, but only I block is coming up, and if everything is filled, it gives the game over screen because it is less than row 0. So we have checked valid and positioned it.